Okay, today, this is technically 9.3 infinite series, and we've already done some infinite series in my classes. And so hopefully, if you are watching this video at home and you really need to just know about infinite series, you should actually go back a few days in the videos because today's going to be short on infinite series. We'll do some of that. We're going to do a lot of review of what we did before break because this is the day after winter break, and we just have had 2 weeks to forget everything. So I'm going to kind of try to jog your memory a little bit. 4, 6, 8. And if you keep going, would you agree you'd eventually hit 20? That is not an infinite series because it stops, right? But there's formulas that you can use to like add up what the total is. I have them listed. Now you can't see them at home, but I'll write it on the board once we've determined which one it is. On the board, A, B, C, D, or E. One of those is the right formula for adding this up. Would you agree that we have to determine if we want arithmetic or geometric because they're kind of categorized? All right, so is this arithmetic or geometric? Arithmetic. When you add each time, it's arithmetic. How can you tell it's arithmetic? You take this divided by that. Nope, that would be to find the common ratio. That is if it's geometric, if it was divided. If you subtract, you go 6 minus the 4 and you get 2. You subtract that one or you subtract this one, you better get the same thing. That's finding the common difference. So a little terminology there for you. Do you remember doing this, the summation thing? And it would be the summation from n equals 1 to, how many terms are there? 4, 6, 8, 10, 12, 14, 16, 18, 20. Appears to be 9. 9 terms. And I'll show you a fancy way you could have figured that out other than counting them up. Try to write out the rest of this, and I'll give you a hint. It involves formula A, which is this. And that's how you write this as a series. Not an infinite series because it's not going to infinity. It's going to 9. I'll pause for a second while you give that a shot. All right. Okay. Did you say that the A in this case was 4? And then n minus 1. Why am I not putting in an n? Because I need to leave it there. If there's an n here, I need to put this variable in there also so that the 1 can go into the n. All right. And that D is the common difference, which we figured out was you're adding 2 each time. Do you know why there's n minus 1 times that? The reason there's 1 less than the total, again, in this case, there's 9 terms. Why don't I add 2 9 times? Because you only need to add it 1 less than however many you had. Let's say that I was only adding up these 3 things. Do you get I would add 2 twice if I have 3 terms? I'd only have to add 2 twice to get to that last term, right? 1 less than however many there are. That's why there's an n minus 1 there, because it's how many little swooshes there are. See? There's 2 swooshes if I'm going to add up 3 terms. And if there's 9 terms, I'm going to have 8 swooshes. 1, 2, 3, 4, 5, 6, 7, and then the 8th one would finally hit the 20. All right, so again, it's always 1 minus however many terms there are, so n minus 1. So why is this sequence finite? What number makes it finite? Yes, it's a 9, because if the 9 was a what? Infinity, then it would be an infinite series. Do you get if I put an infinity here, it means keep doing this forever? You keep putting the 1 in forever. All right. Alternately, I could give you this and see if you really understand what's going on. Expand this and tell me what its first 3 terms are, and then tell me the answer. This is a review part. What are the first 3 terms of this series? And when I say what's the answer, what I'm asking you to do is actually sum them. That's what this is. This is a summation. I'll pause where you try that. Okay. Just tell me the first term, Mr. H. How did you get -5? Stuck the 1 in there, and you get 2 times 1 is 2. 2 minus 7 is -5. Cool. And then why am I putting a plus there? It's the sum of all the numbers in the series. All right, what is the next number in the series? -3 is correct. You stuck in a 2, didn't you? Change this to a 2, and then you stick in a 3 because that's the last one we have to do. And Ben, what did you get for the third term? All right. And when you actually add these all up, did you get -9? Raise your hand if you had that one right. Okay, good. Okay, that was a sum of not geometric, arithmetic series. All right. What if I started with this and I had said, write me the summation? Well, you'd say, okay, well, I know it's got to be from 1 to 3. You get what I'm saying? There's 3 terms, so it has to go like that. But how do you get this part? Yes, it's one of those. There's an app for that, right? Let's grab one of those formulas off the board, and it says a plus n minus 1 times d. And you would have said, oh, I know the d. It's going up by 2 each time, right? So I got to put a d as 2. And I need to leave the n in there because if you have an n here, you need an n there. The last one's the a. It starts with -5. Why does that look different than what I had before? It's just multiplied out. It's the same thing. It's just not multiplied out yet. Okay, so if I multiply it out, then I'd have sigma n equals 1 to 3. And then if I actually do this 2 times n, I'll have 2n. And then I go 2 times the -1 is -2 plus the -5 makes the -7. So it is the same thing effectively. All right. How many of you feel like you understand the arithmetic side of things? All right, I'm going to stretch you just a little bit then. I want to know, well, if it goes like this, I will answer your question in a moment while they're answering this question. I'm going to add 7 each time. What would the 5th term in this sequence be? And write it as in sigma notation, and then figure out the answer. Figure out the 5th term, write it in sigma notation, and find the answer. Now the answer you can get by either finding all the separate terms and adding them up, or there's a formula for that. Formula B up on the board. Yes, sir. Mm-hmm. Option A, best because it's all multiplied out. Option B, also okay. All right, so you're supposed to find the 5th term. And then you're supposed to know how to add up all those 5 terms. To find the 5th term, of course, you can just add 10 each time. Or sorry, 7 each time. That's really not too tough. Or you can use this formula. The nth term, which would be in this case the 5th term, would be a, which is our starting one, plus n minus 1 times d. That formula would come in handy for those of you that are at home. For this b part, where you're actually summing them all up, you might as well use this formula. S sub n is n over 2, which is how many terms there are divided by 2, times 2a plus n minus 1 times d. In case you forgot, that's the little one that little Friedrich Gauss used, where he took the first term, a, and the last term, which is a plus n minus 1 times d. This is first. This is the last term. And you add them together. And that's where this comes from. And then you take half of however many there were. That's the n divided by 2 part. All right, in this case, the fifth term would be I plug in a 5 right here. A sub 5 is the fifth term. And the starting one was 3. And then 5 minus 1 is how many swooshes there would be. 5 minus 1, it's always 1 less than however many terms there are. 5 minus 1 is 4. 4 times the common difference, which is 7. 7 times 4 is 28, plus the 3 is 31. Raise your hand if you had 31 as the fifth term. Okay, good. Then this part, you'd stick in your n is 5 into this formula. How many of you have got this done already? Okay, I'm going to give you a little more time because a lot of people haven't. If you are done, just relax your brain. Using this formula to figure it out. Question? Good question. They are the same n. They are the same thing. And n is the number of terms that you have in your formula. So in this case, the fifth term implies we have 5 terms. So, did you put in a 5 here and a 5 here? And then what's that a? Miss W? What's the a? Yeah, the original, which was 3, the starting amount. So this becomes 5 over 2 times 2 times 3 is 6 plus 5 minus 1 is 4 times d, which is the common difference, which in this case is it was adding 7 each time. So it would be 7 times 4 is 28. 28 and 6, 34. And then I'm going to go 5 halves times 34. I want to split that up. If you can factor it, you should, right? So I'm factoring the 34 into 2 times 17. And that 2 will cancel that 2. And now it's just 5 times 17. And 5 times 10 is 50. 5 times 7 is 35. 50 and 35 makes 85. Raise your hand if you got 85. Okay, good. Now, the last thing is the summation thing. Who can write this little dealy-bob for this? You all need to be able to. Give it a try and compare it with the person who sits left-right of you. Rows 1 and 2 you're going to compare. Rows 3 and 4. Actually, I'm going to compare you right now. So, what do you say? This goes to 5. You're correct on the bottom. For what you're saying, from 1 to 5, that means it implies there's 5 terms. I like it so far. Nice. And what's that 7 called? The what? The common difference. Very good. That's it. Now, could you have multiplied that all out and got 7n minus 4? Yes, that also works. Any questions on that? Okay. So that is arithmetic. Now we're going to spend a much less time than that on geometric, but it's the same exact principles. So let's say I had a sigma that was multiplying something out each time, okay? And it was taking 2 and turning it into, let's say times 3 is 6, and then times 3 is 18, dot, dot, dot. And let's say that I wanted to do the first 5 of this. You can tell that it's not adding something each time because when you look at that common difference, it's not the same. So it must not be a common difference, it's a common ratio. So if you can't figure out this part, I will understand that. It involves a formula. Help them out. A, B, C, D, or E off the board. Formula C is correct. And that says that A sub n, the thing you'd put here, is A times r to the n minus 1. Now that you know that, you should know what A is, it's just our starting number. You should know what r is, it's the common ratio. So you should be able to put that in there. And then, I'd like you to actually find the answer, not by finding, I already got the first 3 terms. I know the next 2 terms are pretty easy. You're just going to times by 3 and times by 3. But there's a formula for it. to help out the people at home, what is the formula for actually finding the sum? Which one, A, B, C, D, or E? D. The reason it's not E, E is only used for the kind that go on forever. And we're only doing the first 5 terms. So then you use this one. S sub n is A times 1 minus r to the n all over 1 minus r. And you know r, and you know n. And you know A. A is just the starting amount. So figure out both parts of this. This comes out to a number answer, like 34. It's a lot bigger than that. I'll pause for a second while you give this a shot. Here we go. Hopefully your math is reawakening. We have A times r to the n minus 1. A is just 2 times r is just, well, it's timesing by 3 each time. So 3 to the n minus 1. Well, what's n? I have to leave an n in there because I need n equals 1 to 5. Raise your hand if you had that part right. Okay. That's the first part. The second part is the sum, where you actually stick in the numbers here and here and here and here, and it gets to be a little bit largish, but especially this r to the n part. But anyway, A is 2 times 1 minus r. What is r in this case? 3 to the n minus 1, which is what? N is 5, so 5 minus 1 would be 4. 3 to the 4th. Now that is not an impossible number, though, because 3 to the 4th is just this, and that's 9, and that's 9, and then 9 times 9 makes 81. Oh, am I doing something wrong? Oh, it's just r to the n. It's not n minus 1. My bad. So that's 81 times one more thing. 81 times 3. 8 times 3 is 243. So then all over 1 minus r. 1 minus r in this case is r is 3. So it's 1 minus 3 is negative 2 on the bottom. And the 2 and the negative 2 can cancel each other out and leave a negative behind. So the answer is negative of this, which is also negative, which makes it positive. 1 minus 3 to the 4th is 1 minus, what did I say that was again? 200, what was it? 243. So the final answer becomes 2 is positive 242. Whew. All right. And why is it not negative? Because it was divided by a negative 1 from this. All right. That's the big summation of a bunch of geometric terms. But then there's infinite, and that's what we're really going to be assigned today, and we've already talked about, but what we're really digging into is infinite geometrics. Now, if I go 2 and then I times by 2 and make it 4 and I times by 2 and make it 8, do you get the problem with adding this up to infinity? If I keep adding them infinitely, isn't it just going to keep bigger and getting bigger and bigger and bigger? Yeah, it seems like that is impossible, and it is, because it'll just keep getting bigger. The thing that's weird but true is that you can reverse this and actually find out what it adds up to, cutting it in half each time. 8 divided by 2, or multiplied by a half is 4, and then 2, and then 1, and then it seems like you're going to have to keep adding things forever, so shouldn't it just get infinitely big? No, you can actually do this. There's an app for that. And it is S equals A over 1 minus R. So if it's shrinking, this will work. You can actually find out the total. So 8 plus 4 plus 2 plus 1. Should I actually just keep adding them in my head? That would be a little bit painful, especially when you got to the part where you're adding like 1 plus 1 over 64 plus 1 over 128. So use the formula, and it's S equals A, which is starting amount, over 1 minus the R. 1 minus, in this case, R is what? How do you get from here to here? Times a 1/2. And that I could have gotten by taking 4 divided by 8. Gives me the 1/2. All right, so that's 8 divided by a half, which is timesing by 2, which is really 8 times 2, 16. Raise your hand if you had 16. Okay, good. Then devil's in the details. When won't this work? If it's increasing, how do you say that in terms of R? R has to be less than 1. You're right, so it goes between -1 and 1. That's what R is allowed to be. And your question might not be as simple as find me the sum of this. It might be find me why isn't this working, or find me what's, something complicated about the formula like that you have to know R only works between -1 and 1. All right. Next, if I do give you a tricky starting number, it starts with 1/16, and then it goes to 1/32, etc. And I only want the first 3 of them added. That would be a finite series, and you'd have to use this Sn a 1 minus Rn all over 1 minus R. That was a really painful one. But if you make it infinite, it's actually way easier. Have you caught on to the pattern yet? Anybody know this answer already? Okay, well, let's actually just ask you, if I do the sum to infinity, which would be like this deal, would you tell me what the infinite sum is? Use the little formula. What's R in this case? 1/2. And therefore it's 1 minus 1/2, and therefore it's going to be really 1/2, and therefore it's A, which is our starting number, 1/16, divided by 1/2, which is the same as times it by 2, and therefore, so if you're cutting in half every time, you can just double the first number? Okay, so 1/16 times 2 is going to be 2/16, also known as 1/8. It's that one doubled. It's easier to say it as 2/16. Yes, sir. That only works for 1/2, but there's an interesting pattern that develops if I do a bunch of them. All right, given the amount of time that we have, I'm not going to delve further. Just know that formula and be able to use it. S equals A over 1 minus R. Make sure you can only use it when R is between -1 and 1. Can't be bigger than 1. Can't be less than -1. And here are some problems that you can do to practice that. Starting, it's a little deceiving because it says a bouncy ball lab, which we are going to do, but later. It's actually really cool, and it decreases. The ball bouncing gets lower and lower. It's a decreasing series, right? So we should be able to add them up. It'll be kind of interesting to see how far the ball actually travels. All right, but it's not assignment day 2. Right after this big slide says assignment day 2, it says day 1. So anyway, watch for that. That's where your assignment starts, and you're going to do all the problems up and through and including number 7. So these two, this one, and number 7. That's your homework for tonight. Up through and including number 7. All right. Well, we could start this one together. Number 2. An arithmetic series has a first term of 2. Okay, I'm going to start writing it. 2, comma, and a fifth term of 30. Okay. Second one, the third one, the fourth one, the fifth one is 30. Get how I did that? To kind of like make sure I knew that it wasn't just the next one in line. A geometric series has a common ratio of -0.5. That's a different problem. See, this is arithmetic. So now we got to do one for a geometric. I'll do that in blue. It has a common ratio of -0.5 or -1/2. So this one, I don't exactly even know what it starts with, but I do know that each time it gets multiplied by negative a half to get to the next term and the next term and the next term and the next term. Okay, the sum of the first two terms of the geometric series is the same as the second term of the arithmetic series. Well, it's not too hard to figure out what the second term of the arithmetic series is. Let's do that one. Do you get how we can figure out what this term is of the arithmetic series? Well, which formula should I use? Okay, a sub n is a plus n minus 1 times d. That's the formula I want to use, because I'm not actually adding all these terms up. What does that tell me? That tells me any term. So let's try the 30 in there. If I had 30 was my term, and it started with a 2, plus, do I know what term that was? Yeah, it was the fifth term. 5 minus 1 times d. I don't know the common difference. That's the whole point. So solve for d. You get how you can solve for the common difference there? All right, so this is 30 equals 2 plus 5 minus 1 is 4 times d. Then subtract 2, 28 equals 4d. And d must be 7. Yay, I add 7 each time. So do you get this must be 9 right there? All right, piecing together, one little piece at a time. The sum of the first two is the same as the second term of the arithmetic series. So you're saying this plus this is equal to 9. And those two things, which I might call x and y, x plus y is equal to 9. And would you agree that x times negative a half equals y? What I just did there? I wrote out a little system of equations. Because this times the common ratio gives me that. Now from here, it's easy to solve. I can solve this for y is equal to negative 1/2 times x. So I'm going to put that wherever I see a y, which is right there. So x plus negative 1/2 x has to equal 9. And when I'm done, remember to answer the question they actually asked. What is the first term? All right, so this is not just your simple little, like, here's 4 numbers and try to do the series on them. Okay, this one is that simple. Here, I've got 27, it's going down to 9, going down to 3, going down to 1/3. Do you get there multiplying by 1/3 each time? Okay, so then the common ratio is 1/3. Since that's the r and it's less than 1, I should be able to actually add this up. Do you get that the dot, dot, dot means forever? So they're really asking you to do an infinite series. So again, I can't even start this problem until I pull in a formula. Formula in this case, s equals a over 1 minus r. And I know the ratio this time. The ratio is 1/3. So I put a 1/3 right there. A is my starting amount, which is 27, goes right there. And it's a piece of cake from there. Okay, how about on this next one? It's not so easy to see that it's just like multiplying by 1/3 each time. So how do I tell? I take that and divide it by that, and that will tell me what the common ratio is. That'll tell me r. Or if you'd rather, take this one divided by this one. That'll tell you r. And I'm going to, in this case, take negative 3/10 divided by 1. Dividing by 1 means it's just the same thing, so it's just negative 3/10. I keep multiplying by a negative, it's going to get how it's going to change back and forth between negative and positive. because then you'll have a negative number multiplied by a negative makes it positive. And then you multiply by a negative makes it negative. That's how it changes back and forth between positive and negative. All right, so I know my r. Divided by 1 just means itself, right? So there's my r, and I need to know starting number, and I have that, and then I just need to put it in the formula. No big deal. How about on this one? If I multiply by, or if I add something each time, sorry, subtract something each time in this case, negative 50, it's not going to be subtracting the same thing each time. Do you get that? So this can't be an adding one. Must be a geometric again. And so as soon as you know it's geometric, you can just take that divided by that. Or if you'd rather, take that divided by that. And that'll tell you your common ratio. And you know r. And you can just use this formula. S equals a over 1 minus r. All right, you're going to be using formulas a lot for these. This one, second term of a geometric. Okay, right away, am I doing a sum? Oh, the sum. I know the sum. That means I probably use this formula. And you know the sum. The sum to infinity is 64, so I can put that right there. All right, I'm not going to do all of them for you, but I want to get you some set up so you can see they're not impossible. They're doable. And that's all I have for you for today.